Good afternoon, everyone. Hello and welcome. Welcome to this, the last session that we have on day one of this year's ESN Marketplace event. It's been a really interesting event so far today, yeah, we hope to continue that for the last session now. As we let people start to filter in, I can see we've already got 30 to 40 of us already piling in, so great to see you back. Do dive into the chat function, introduce yourself, maybe let each other know whether this is your first ESN event that you've attended, or whether you're a hardcore veteran who's been at the ESN Marketplace. I think Madeline, my colleague, mentioned it's been going for 10 years. So yeah, it'd be great to know if anyone was at the first one and has made it all the way through to 2021. So for those who have joined us, welcome. If this is your first session, or if you've been with us for the whole day, welcome back. My name is Raoul. I'm Head of Technical Development here at Regen, and I'll be guiding you through this final speaking panel session of the day for the Marketplace, which is all about proving the case for long duration storage. A topic that has been raised a couple of times across the day, which has been no surprise to everyone involved in the storage sector. So we'll be really digging into long duration for the rest of this session. It would be good to sort of, at this point, for the last session of the day, to thank our sponsors for this year's Marketplace event. Fluence Energy, Schneider Electric, Modo Energy and Friets. We really appreciate their support for helping us put the event on this year. I also want to give a big thank you to my colleagues in the background who have helped make the event seamless and making sure that everything keeps running for today. So my colleagues, Hannah, Estelle and Madeline, many thanks for their support as we get through the first day. For those who do not know the ESN, we are the voice of the UK electricity storage sector, and we're one of the only independent, dedicated industry organisations to supporting electricity storage development in the UK. The ESN is managed by Regen, and myself, along with my colleagues who you would have heard from today, manage our working groups, the work that we do on policy and insight to support storage, alongside as well our fantastic membership. So if anyone is interested, from what you've heard today, in joining the ESN, we'd love you to join us and continue the work that we're doing. Before we get into the session today, a bit of housekeeping on the guidance on using the platforms that you see. So we're using a couple of platforms here. The event is hosted on Hoover, but you may also have joined us in Zoom as well. If you haven't done so already, I encourage you to download the Hoover app, which gives you a few more facilities. And the platform itself will have information about the sessions that have happened before, networking potential. There's a community board. You can speak to the speakers and the sponsors and the other attendees. And also there's some downloadable, streamable content that you can have a look at as well. There'll be a couple of podcasts landing on the platform tomorrow. And there's a great set of videos from one of our sponsors, Modo, that you can watch on there as well. So do jump on the Hoover platform. This session will be a panel discussion. We won't have any presentations. So it's going to be led by some sort of upfront questions that we have on some particular topics, but we will be opening the floor to questions from you guys as well. In order to do that, please use the Q&A function, whether you're in Zoom or in Hoover. The Q&A function on Hoover will be on the right-hand side control panel, and for Zoom, it'll be along the bar at the bottom. Unfortunately, we won't be taking any live audio questions. We won't be using the raise hand function because there is 115 of you in the room right now. So that would be quite tricky to manage, but please do dive in on the chat if you want to continue the dialogue as we run the session, and we'd love to see your questions. So I think that's probably covered the introductions and the scene setting onto the session today, long duration storage. So Bayes describes storage as an essential source of low carbon flexibility. And as we've seen across the day, there's a lot of interest to connect storage technologies, but it's probably fair to say that the pipeline that we see is predominantly focused on short duration battery technologies, providing rapid response services. So the focus that we've had in ESN recently and this year, we wanted to explore the opportunity and the topic, essentially, of long duration storage. This is a topic that government has directly engaged with this year. With, I think Hannah Clapham was actually on one of the sessions this morning, talking about the competition fund to support long duration storage, the call for evidence about the use and the opportunity for it, as well as modelling the system need. So we want to continue that dialogue with you all today and with my panelists to understand the potential, the need for long duration storage, and essentially prove the case for why we need it. So I'm delighted to be joined by a fantastic panel to discuss this topic with me today. So we have Shona Watt, the market strategy lead at National Grid ESO. We've got Priyanka Mahaptra, who is the Grid and Regulation Manager at Scottish Power Renewables. And we have Gary Preece, who is the Power Systems Director at Highview Power. The format will be, I have some questions that I'm going to pose to my panel for the case for long duration storage, and each of them will give a perspective from where they come from, and then we'll essentially rotate around them and come out to you guys for some additional questions to see if we can prove that case. So without further ado, let's bring my fantastic panel into the conversation. I'm going to start off with a simple question. Can you give yourselves a bit of a brief introduction to yourself, your role, and the organisation you represent, and why you are interested in long duration storage? So I'll come to Shona. Shona Watt from National Grid ESO first. Over to you, Shona.
Good afternoon, Ray, and many thanks for the opportunity to be involved in what I'm sure will be a fascinating discussion this afternoon. So yeah, my name's Shona Watt, and I'm the Market Strategy Manager at National Grid ESO. And my team was created just over a year ago to tackle the very important question of essentially whether our current market structures and policies are fit for purpose to deliver net zero. So within that, we're looking at the full suite of electricity markets and policies, so not just those that are naturally led by the ESO. And we're doing that in a very long-term context. So we're looking out towards CB6 2035 targets and ultimately to net zero 2050. So why are we interested in long duration storage? Well, we have broken the overall market design down into 5 first order priority elements as outlined in our publication that we released in November of last year. And one of those really hones in on the flexibility question and really asks, the extent to which there should be central planning in the flexible asset mix. And that kind of also includes the sub-question of whether there should be an explicit target for any flexible asset subgroups. So yeah, this is very much at the heart of the questions we're addressing in our net zero market reform project, which is the flagship project of the team. So yeah, looking forward to a great discussion this afternoon.
Thanks, Shona. In the heart of the issue, which is we really appreciate having yourself with us today. Priyanka Mahaptra, who is the Grid and Regulation Manager from Scottish Power Renewables. Over to you, Priyanka.
Hi, everyone. So yeah, I'm Priyanka Mahapatra. As I've been introduced, I am the Grid and Regulation Manager working within SP Renewables, Scottish Power Renewables. So we are one of the largest wind farm developers within UK with with gigawatts of wind power, and also in pipeline to be connected to the network. And we already own and operate large-scale wind farms such as Whiteley and East Anglia on the network. Our interest in storage has been developing over the years as we look forward to supporting not only SP Renewables, the wider Scottish Power Group and the wider Iberdrola Group looks forward to supporting the grid and the ESO in our journey towards net zero. So we are committed to it, and we are looking at all technical solutions that will facilitate this transition. We have already started deploying storage technologies on the network, and our interest is only growing in long duration storage as we keep an eye on how the market evolves, what are the use cases for it, what are the price signals, and overall, if what we want to assess and understand for ourselves is how this will help driving the cost down for the GB customers in moving as we move to a net zero system. So, and that's my brief introduction, and I look forward to answering your questions.
Thanks very much, Priyanka. And finally, Gary from Hy-Vee Power.
Thanks, Ray, and thanks everyone for joining us on this panel. So I'm Gary Priest. I head up our power system development side at Hy-Vee Power. We have a long duration energy storage platform, and we're in the process of entering in our first construction phase with our site at Carrington, and then moving swiftly into the program of solutions that we're about to install onto the system. You know, I'm really interested to see how long duration energy storage plays out and its usefulness on the system. We're very, very confident that our particular platform, which has retained its synchronous heritage, can be a real support of the system, both in the megawatts and at 0 megawatts. And yeah, and I think some of the questions that we'll get posed today, I'm looking forward to hopefully answering and demonstrating that actually there's a need right now for long duration energy storage. I think there's a place for it on the system. The opportunities are there, and yeah, I'm looking forward to debate that.
Fantastic. It's great to see the sort of 3 different perspectives on this topic, which hopefully is going to sort of enrich the conversation we have. So let's talk about today. Let's start with that. We've touched on it a bit today, but we've done some analysis with myself and some colleagues around the size of the storage pipeline in terms of megawatt of power capacity. And, you know, if you look at everything that is classified as a storage asset interacting with the system or the planning system in some form, there's about 34 gigawatts that's in various stages of speculative development through to almost being built out. But when do you think we will start to see long duration technology start to sort of feature in that pipeline and become a significant part of that? Or maybe put more simply, is long duration storage projects beyond trials attractive to develop today? And maybe I'll come to Gary first on that one.
Yes, so like I said earlier, we've started our construction program in the first one, which is it's a 50 megawatt, 300 megawatt hour system. We're really confident. We've seen a business case, a merchant case, dare I say, within its current location at Carrington that gives us confidence to deploy now. It's the smallest one that we'll install. The next one will be 2.5 gigawatt hours, 200 megawatt discharge with 100 megawatt charge capacity. And throughout, we've used various analytical companies to sort of qualify our thoughts, deploying this technology on a merchant basis. Totally believe that it's right now. The volumes are there from congestion alone at the moment, and Shona would agree. I assume that the value is there from wind curtailment. It's the right story to be telling, that we don't curtail wind anymore. If we can store it effectively, and it's all about being in the right location. You know, I think that's one of the main benefits of long duration storage. That's locatable. You can put it in the right place. You can help the transmission system. You can reduce curtailment, reduce CCGT actions. Then it's ready to go now for me.
Okay. Thanks, Gary. Great to hear. Priyanka, your thoughts?
So someone actually asked a question that I just saw in the chat. So I will try to define what long duration means and then try to put it in the context of why we think it will be viable and needed for our future. So long duration, first to start with some facts, the cost of storage is decreasing. We see as we deploy more storage, the value per kilowatt hour also falls, system cost also falls for the customer. We also see that storage can smooth out hourly and daily energy requirements, and that's been already proven. when we talk about long duration, in my mind, I'm not thinking about smoothing out this daily gaps in generation demand. We are thinking that on a more longer duration, maybe weeks or months or even seasons. So for example, if you take California as an example, anything less than 10 hours there is not defined as a long duration storage. I'm not saying that's the definition we should stick to, but that's what we are talking about. And the basic characteristic of long duration storage is that they have a high energy to power capacity ratio. That means they are designed to provide the same level of energy or power over a longer duration of time. So having said all that, the 2 points that factors that come up is, first of all, they will have a lower utilization rate. So battery storage, we can cycle it up and down many times a day, and that's where we drive the revenues from. That's where we get paid from. However, when we come to long duration, the utilization rates might be smaller, but the amounts of duration that we want to store the energy for might be longer. So when we do the levelized cost against that, we will have to understand it from business case by case, but they do overall remain quite high, the levelized cost of storage for long duration. So I would say there is a lot of promise, and if we really do want to move to a net zero system where we don't want to rely on any fossil fuel generator, if we want to move to a net zero system which we can operate reliably, and reliability being a very key factor here. So if we just, when we have no power, we don't care, then it's not a problem, but we have to operate our system reliably, then a long duration storage will be required, and in order to drive the system overall system cost down.
Thanks very much, Priyanka. That Californian benchmark is a really interesting comparison. They've made a sort of definitive threshold there. That's really interesting to hear. Shona, long duration storage, is it something that system operator could make use of today if a project came to you to deliver it? Is it something you could use?
Absolutely. Well, clearly long duration storage, many of these technologies offer significant operability benefits in addition to the energy benefits themselves. It's important that all of those additional benefits are properly monetized, and that the operators can stack revenues where appropriate to basically present a fair reflection of the aggregate benefits of LDES compared to other technologies. I mean, to go back to your original question, Ray, I mean, yes, I think it's clear that the current storage pipeline overall is dominated by the shorter term battery technologies. I think looking forward more to 2050 horizon, I think the key sort of factor of when LDES becomes more part of an optimal overall asset mix is the percentage of intermittent plant, renewable intermittent plant on the system overall. I think studies have suggested that once you get beyond a sort of 70% penetration of intermittent renewables, that's when you really see the tipping point in terms of longer duration storage, providing significant benefits compared to some of the competing technologies at either end of the duration of storage spectrum. So obviously at the shorter end, you've got the battery technology. So I guess there's a little bit of a gray area between, Priyanka mentioned the 10-hour definition. So a little bit of a gray area in what might be most economic between, sort of anything from sort of 5 hours to 10 hours. And then of course, at the other end of the scale, hydrogen may be a more economic option for duration, storage duration periods greater than around a week or so, perhaps. So the optimal mix is something that clearly the ESO has done a lot of work in actually trying to model how that may evolve over time, but it's clearly subject to many uncertainties. And we're keen to explore the role of LDES, and one of the key questions we're asking in our net zero market reform project is, should there be a dedicated subsidy for longer duration storage? And if so, what may the appropriate form of that be? So yeah, be very interested to hear the other panelists' views on that key question.
Yeah, it would be definitely good to talk about incentivization. If we've touched a bit on there on the horizon. So, the transition of the electricity system and the energy system in the broader sense. The future energy scenarios that National Grid put out, the ESO put out last year, suggested that electricity demand could range between 400 to 500 terawatt hours in 2050. So, as we sort of move to that scale of electricity demand and electrification of our heat and transport, what use case do you see long duration storage playing in supporting that transition? Maybe I'll come to Priyanka first on this one.
Okay, so I'll bring the point back to reliability. So the way we know that renewable generation is intermittent, so there are two ways of handling the reliability question. We can either build a lot of renewable generation and overbuild, and in terms of capacity, and make sure that should probably help in saying, okay, that we always have generation connected somewhere, but that's not feasible cost-wise, because that means that we need to invest a lot in the network and manage the constraints and everything. So we will have to look at a solution which also drives down the system cost. So in that, if we actually, as Shauna mentioned, if we do some modeling and analysis, and that's been done across US and Germany and others, you see that when you put long duration storage in the mix, that drives the overall system costs down. So if when we talk about driving, so if on three factors, driving the system costs down overall through operation of long duration storage, maintaining reliable connections, reliable electricity supply in future, we can't do that without long duration storage. Either we look at long duration storage, or we look at keeping some of the conventional power plants still on the system, which is not what we want going forward.
Okay, thank you, Priyanka. Gary, what about yourself? What do you think? How can long duration storage support the electrification of a lot of our demand?
Yeah, I think one thing is important, and I'll probably just keep going on about this, is location, and is it more than just megawatts that your energy storage system can provide? Can it help the transmission itself? A lot of renewable energy comes in one location, it gets built a lot faster than the transmission capability is built out. And so you have to really rely on the fact that, can your long duration energy storage system also provide some stability services? Can it be used in regulation, etc.? And can it even free up some of the transmission bottlenecks? And that's what we're going to see is, it's no, I mean, everyone knows that the renewable generation gets built out a lot quicker than transmission can change. It gets built in sort of clustered areas, which brings its own operability issues for the National Grid as well. So it's, can you, as part of your deployment of long duration energy storage, help with that sort of operability piece? And if you can, then obviously that's going to add value to your platform, which is going to, as Shona spoke about before, if you can stack these revenues, in particular, can you provide stability services outside of having to deliver a megawatt when the wind is blowing significantly and solar is in play? Or do you have to rely on your system to do it when delivering energy, etc.? So location for me, the ability to help with transmission constraints, etc., and being there as long as you can be, especially for regulation, etc.
Great, thanks, Gary. So Shona, you've heard there from Priyanka and Gary, stability, helping with sort of demand clusters. In the future, is long duration storage going to become one of the system operators' biggest allies in this transition?
Well, looking at the different challenges that we're going to face on the pathway to net zero, we actually did some modeling to support our net zero market reform project that looked at the case for change, and in that process we essentially extrapolated the current market design to sort of 5-year snapshots into the future, and saw how some of the key outcomes of the market would evolve accordingly. And we looking at those outcomes, we drew out 3 key challenges that we needed to overcome on the journey to net zero. So the first was regarding really an unprecedented scale and pace of investment overall to meet the hugely increasing demand that you referred to there, Ray. And Priyanka's already touched on this trade-off, potential trade-off between incorporating more long duration storage into the asset mix in order to reduce our reliance on thermal plant. However, it wouldn't necessarily be unabated plant. You know, we could have the opportunity to reduce the need to have what otherwise might have to be a very long tail, so to speak, of peaking plant, which could be, you know, hydrogen OCGTs, for example, very, very low load factors, but would nevertheless need to be there for the Dunkelflaute periods of still wind. There's an inherent trade-off there in terms of potential for long duration storage to offset some of the additional capacity requirements on the system overall. And then I think we also identified the need for assets to locate and dispatch at locations that will reduce the overall cost in the system. And this is obviously the point that Gary's already picked up on. Yeah. And clearly all storage can potentially be, you know, dispatchable and can help resolve constraints. But I think one of the interesting things about high-use technologies with the cryo batteries is that geographical portability that probably doesn't apply so much to, for example, other forms of long duration storage such as pumped hydro, which clearly is to a certain extent limited by considerations of the actual the suitable sites that tend to be in many of them in Scotland and Wales. So so all 3 of these areas, you know, long duration does have the potential to make a serious contribution to the overall asset mix.
Okay, great. So we've touched on, you know, the interest today. We've touched on the potential sort of use cases and services that long duration storage can provide. Let's move on to incentivizing these projects to be built. So obviously Gary and his team are already looking at building, and so Priyanka. But the long duration call for evidence that we mentioned at the start, the ESN actually responded to that and engaged with our members around it. And one of the interesting things that came out of it was the characteristics of large scale long duration storage. There are essentially 3 elements that you could look at: the big power, the big scale of the project, the potential for it to charge up or discharge for long periods of time, or the potential to store the energy over long periods of time. So there are sort of 3 facets of long duration storage that you could look at. In your view, which of those characteristics should we be incentivizing to get projects built or more capacity built, and really, you know, seeing a growth in long duration storage as a sector? Is it one of those? Is it all of those? Or is it something else entirely? So should we be having a subsidy for or a target just to like incentivize it in a different way? So maybe I'll come back to you, Shona, actually first on this one.
You know, that's really is a great question, Ray. And I think to a large extent is one that was has been maybe evaded more than it should have been, despite the point we've got to now in some of the discussions for the different incentive mechanisms. I mean, I guess if you really strip it back, you know, policy interventions should be a last resort in principle. Yeah, so we should ideally have a market that's able to deliver the optimal asset mix. If a market is designed efficiently, it should be able to do that without policy interventions from a pure sort of a purist economic perspective. So the perspective we're taking in our Net Zero Market Forum project in the 3rd phase of our project is to start with actually addressing the wholesale market itself, and whether sharper wholesale price signals across space and time might start to fill some of that gap in terms of the overall revenue requirements of some of the LDS technologies, which you might not call them nascent, but perhaps adolescent, to achieve full commercial scale in this country at least. So I think this is the natural starting point, and then you're left with questions which relate to whether there's any inherent additional characteristics of the plant that are unpriced by the wholesale market. So clearly the operability advantages in terms of inertia, very important, that Gary mentioned is a good example of that. So they would have dedicated ancillary services revenue streams associated with them. But then, you're left with the question, well, is there any other innate characteristic of long duration storage that merits additional subsidy, essentially? And I'm not sure the industry has truly got to the heart of that issue yet. But yeah, very interested to hear Priyanka and Gary's views on that.
Thanks, Shona. So yeah, Priyanka, what element of a long duration storage asset would you like to see incentivized, or is it none of those things? Would you like to see incentives coming from a different perspective?
Well, we'll be open to any incentives coming that give us the clear signal that long duration storage is required. However, I'll take a slightly different view. We're talking about stacking and actually comparing, adding the services on top when we talk about long duration storage. I would say just putting another spin to that and just kind of thinking in a different way, how if we separate those two, because we do have really good technologies in short duration storage, which are, for example, lithium ion batteries, which are going towards 4 hours, 6 hours durations, which can, in a way, there are longer duration. So they can stack up a lot of services when it comes to, say, wholesale pricing, providing the short-term power intensive applications, such as just giving a burst of power when it comes to inertia support, inertial response, or frequency response. However, in my mind, the role of long duration storage can be stretched out. So Shona mentioned peaking contracts, forgetting day ahead peaking. If we look seasonal peaking or months or days of peaking, the feature I would be most interested in from that perspective, or we should be most interested in that perspective, is can we store for longer durations, then discharge for longer durations? And that would be the most interesting feature. And that will then separate the fields where both technologies, short duration storage and long duration storage, are competing. I'm not saying that's the right answer, but that could be one of the ways of looking at it. And so we don't actually, de-incentivize one technology by putting the other on the network. Being a developer, since we are deploying short duration storage, or what is perceived as short duration storage on the network right now, obviously we want this to also be on the network and supplying the services for a longer time. So I think it's an open question, and it's something that needs to be debated. I don't think anybody has the right answer right now. We will just have to evolve and look at the cost and the cost to the consumer, most importantly, and seeing that where does long duration storage really start making sense in terms of system cost to the developers, in terms of its performance. And one of the ways could be just separating the use case for short duration storage and long duration storage, and making one more power and short duration energy intense, and the other more based on energy capacity for longer durations.
Great answer, thank you. I think it's really important. There's a question that's also coming about sort of cost to the system, the cost to the consumer. So obviously incentives are driven from that ultimately. It's a really good point. Gary, to yourself, you're developing projects. You mentioned a 200 megawatt, 2 gigawatt hour project. What element of that project, or what capability of that project would you like to see rewarded for you to be able to develop more?
I mean, we're really fortunate with our platform that we can, as I said before, we can do the real congestion management side of life. You know, the bigger plants, and which would be actually be our grid entry plant, it can charge for 40 hours. So you can imagine that could be seen as downward regulation, which would reduce the amount of reserve that would need to be kept by grid as well. So there's a value in that. It's then got around about a 12.5 to 15 hour discharge. It's stability island, which can be used at 0 megawatts, providing short circuit inertia and large values of reactive power, which at certain locations is extremely valuable to National Grid for their operability side. And it's also about not taking up lots of infrastructure. If you wanted to get some fast frequency response, dynamic containment, then some short circuit, some voltage control, you're starting to eat into transmission assets, extension of substations, etc. The idea is to try, if you can analyze the system and locate where you'll be able to maximize your performance on a location benefit, then even today the signals within the BM, etc., and potentially some contracts around provided regulation or voltage support, we see the signals are strong enough to be able to go today. Of course, a lot of that is driven by subsidy for the wind and the cost of constraints and curtailments, etc. Even when that goes, which it could be 10 years down the line, there is that thought of, you know, is this something the wind is going to be able to use when they start to see these negative prices and they're not able to be constrained off, they have to come off themselves outside of the subsidy. You know, we see a real long-term benefit starting today for long-duration energy storage.
Okay, so that's really encouraging to hear in terms of the theme of this session. There are value streams already present, and there are more to come. And the market reform work that the system operator and Shona are doing should sort of reveal the other market potentials that may come as well. So it's really interesting. So there's some great questions that have come in into the Q&A. So I'm going to turn to some of those at this point. So Ajay Ahuea has raised a question about planning, which I think is a really interesting one to touch on. So I think it's fair to say that energy projects historically and planning have been focused and themed around megawatts. That's sort of dictated their physical size on the ground and what they are as assets. Energy storage is a different consideration. You know, the energy storage capacity rather than the power is probably going to dictate its footprint and the technology type and what it does and looks like on the ground. So, you know, what does the panel think about getting these projects or long duration storage through planning? What's been your experience so far, obviously, for two of you who have developed these assets, and how might that evolve? I'll come to Priyanka first on this one.
So just to be clear, we haven't developed long duration storage yet. We are looking at the proposals for it in future and what the prospects are. So yeah, that's a very good point about planning. Of course, it's a big challenge. What we're looking for is an energy dense system, something in a short area we can get maximum energy possible. But when we then move to the technology that and so we have to first classify what long duration storage is, but generally those technologies tend to take up more space, which does make sense. So for example, if we are looking at a flow battery, probably we'll have to add extra electrolyte tanks, which do take up space. For pumped hydro, you need geographical, you need a hill somewhere to pump the water up to create that whole energy storage there. So of course, planning will play into this, and that's why whether we can co-locate with a wind farm or we will have to go to a separate area to build a long duration storage will always remain a big question. But I think it does boil down to what technology types will be available and how we can best use them. The more energy dense technologies we can invest in, which can in smaller areas give higher energy outputs. And also that plays into the capex of it, getting a permission to put this somewhere, what's the initial cost. All this will drive also the viability of long duration storage. And initially, probably there has to be incentive to the developers overall, and to get this consent, get the whole capex at the groundwork going, so we can put that on the network.
Okay, thanks for that, Priyanka. Gary, planning. Your technology is a really interesting example. You've got various sort of sub-technologies that have different parts of the process. So when you've looked at your projects with local planning officers, have they considered it a storage asset, or have they considered it a compressor site or another piece of infrastructure? Yeah, what are your views on planning? Yeah, I mean, it's been well received for us. You know, it's very supportive to get the storage projects away. We've also been pretty fortunate that England and Wales increased their megawatt for storage from 50 to 200, and that's made a significant difference on the discharge. Yeah, we store our fuel in tanks. You know, it's every part of our plant is recyclable, because it's metal, it's copper, you know, and we've not gone to any sort of materials that could be questionable, etc. I mean, the process has been around for so long, so it's been easy for us to demonstrate this through the planning process, and we achieved planning with no issues at all for the Carrington site, and we don't foresee that being a problem for any of the other sites as well. We do have quite a high energy density, which is good, of course, because it's liquid air. It's not spread out over a long or significant area. So yeah, generally well received and very supported by everyone. Okay, that's also great to hear, and it'd be interesting to see how the planning regime adapts as new technologies come to the fore as well, to see how it's considered. Shona, we've touched on it a bit already, but the cost to the consumer and sort of rewarding the services that some of these assets can provide. You know, the question here from Russell, can the system pay for these systems and the maintenance of them? Is the cost realistic to enable capital investment without placing an enormous burden on the consumer? So thoughts about, you know, how the system operator and other parties can reward and finance these assets.
Well, this really comes back to the heart of the question of whether you know, there should be a dedicated subsidy for these assets, because ultimately, ideally the invisible hand of the market would ideally basically determine the asset mix. And I think, you know, one thing that maybe we haven't drawn out enough is we're sort of bundling sort of long duration storage technologies together in the discussion, but the right answer to some of these questions might be very much different depending on the specific technology we're talking about. I mean, there's a world of difference between Gary's cryo battery technology and building a mammoth new pump storage facility in the Highlands of Scotland, and the considerations in terms of whether what sort of subsidies are appropriate, I think have to take into account those very fundamental differences in terms of the scale of the upfront capex that might be required for new pump storage projects, for example. I mean, bearing in mind that none have been built since privatization, essentially. I think there was another question came in on the chat asking whether UK grid operators are allowed to invest in LDIS after Brexit. So the answer is obviously no, we're prohibited from owning generation under our transmission license. But yeah, just thinking back to the days of, you know, post-privatization, National Grid did still own strategic pump storage assets. It's still owned de Norweg, and until it was subsequently divested to First Hydro, I believe it was. So yeah, in a sense, it is, this is one of the fundamental questions: is that a special case just because of the enormous capex levels required? To what extent should we aspire to inter-tech competition within an incentive mechanism? given the vulnerability of any mechanism designed to the specific parameters or eligibility criteria, essentially picking winners between those technologies. So these are the actual detail of any such arrangements is going to be critical to make sure it essentially achieves the overall optimal mix, which is obviously in the best interest of consumers in the long run.
Yeah, the portfolio approach is an interesting perspective of that. Priyanka, so the cost to the consumer, lucrative rewards for storage assets, incentivization to be built, versus the sort of cost to consumers to where those services are paid for. Should some of that burden be risk on the developer, or should we sort of kickstart the sector with lucrative incentives for shorter periods, for example? Or is there a sort of a sweet spot to be found in that? Costs to the consumer?
Well, there is always shared risk. I think in current markets, we can't ever exclude the risk to the developer completely. Every developer does take a certain amount of risk, no matter what technology they develop. But I don't think that's exactly going to drive down the costs to the consumer, but just putting the risk on the developer. What will drive down the costs for consumers is through proper modeling, identifying exactly where long duration storage is required, and then backing it with a lot of studies to show how it drives down the cost. And we have all the modeling tools, we have the hourly data, and we have the cost, and the modeling has to just of the system has to be extended from hours or days or months to years, probably over the next 10-15 years, and then say, okay, we are hitting net zero, say in 2035. How prepared are we? What is the system cost to consumer? And if you put a long duration storage in there, what difference it will make? Similar studies have been undertaken by Carnegie and Caltech. There are some papers available, really good theses available on internet to read and to understand how they placed long duration storage in there in order to drive down system costs. Someone did ask whether other efficiency methods, such as like going thermal insulation and additional renewable capacity and interconnectors, can reduce the budget. We have to think of it in this way. The storage is looking at the capacity problem with intermittent generation. Yes, we can go with all the solutions, but there might be still patches over the months, say winter months or summer months, when the demand is high and the generation can't meet it because the generation is not there on the network, and it might run for a couple of days instead of just running for a couple of hours when we take off all our thermal generation from the network. So yes, we can address the issues with all these other technology, but overall to drive the system cost down and to be net zero reliably, long duration storage looks like the most attractive option at the point. And the developers should be incentivized to put long duration storage on the network, but overall we have to look at the operation over the years and how it will benefit the customers ultimately before we make a decision.
So it's not just about the services and the incentivization now, but the sort of longer term services. I almost said duration then, sorry. Gary, I obviously appreciate your views on the topic of cost to the consumers as well, but there's another question, if I may, sort of weave in there. So question from Paul Jarman, I think, about how important round trip efficiency is to support the case for long duration storage technologies. Have a look at that one.
Yeah, of course. So if you take, for instance, the approach from lithium ion with it's quite high round trip efficiency, it's cycled quite often, it's in the wholesale market really more than anything. It's, that's a benefit to that. When you look at a platform that pretty much replaces what you're missing, i.e. synchronous generation, if you look at even some of the CCGTs that are the newer fleet are around about 53% efficient, and that goes down with time. They're providing a specific support surface. So if you go into long duration energy storage, that is helping you meet the demands of what those technologies were asked to meet. If you can stay around that efficiency level, given the amount of energy available to you for long periods of time, because there's so much energy that is curtailed at the moment that round trip side of it's not playing a part because it's just not being used anyway. So you've got a lot of excess energy in a renewable world, as discussed earlier, that is available. So it's not so much, it's more about being able currently to handle large volumes of constrained, curtailed energy, and then being around for long periods of time to help support the system in the low wind periods as well. Of course, you wouldn't want an awful round trip efficiency, that would make no sense, but in the longer duration storage space, I don't think between 50, 60, 70 is gonna make much difference, because you need to be up at 85, 90 to be up there with lithium ion, etc. anyway. So for me, not so much for the long duration energy storage players, but very important for the shorter duration multi-cycling technologies.
Useful to dig into that. There's a really interesting question, Shona, from Raymond de Corvette. I think is a really interesting thing to touch on. It's quite eloquent, actually. Who feels the pain of a lack of long duration storage the most across the whole power supply system, this power supply chain? Who's missing it today the most, and who might miss it most as we move forward?
Yes, so this is a really interesting question, which actually brings in one of the points that hasn't been raised so far that I was keen to raise, which is the demand side part of this equation. So when we talk about optimizing asset mixes for flexibility, the danger is to automatically think of the supply side. And yes, so the ability of flexibility, both business use flexibility and domestic residential flexibility in terms of the overall solution is, I think, very much under explored. And the answer to the question there in terms of who feels the pain, well, really, ideally, you need a system where the willingness to pay of different customer types is fully revealed, and that this flows through in the market, such that a system where we get greater rollout, for example, of time of use tariffs for customers, residential customers, would have a great deal of merit in not obviously solving all of the problem, but those customers who were willing, obviously, to reduce demand in periods where margins are tight, actually being incentivized to do so. That there's a clear benefit there, because rather than it just being arbitrary who feels the pain, people are actually demonstrating their willingness to pay or their willingness to reduce demand and respond to those incentives. So yeah, I think in terms of this whole conversation and the relative merits of different solutions, that's something that really needs to be explored more fully in terms of removing some of those barriers to participation from the demand side.
Okay, thanks, Sharon. I'd like to move on. We've still got sort of 7 minutes left. I'd like to move on teaming up, maybe, for want of a better phrase. So the potential to co-locate technology. So whether it's co-locating short duration and long duration as a very, very flexible asset, or co-locating storage and long duration storage with generation, or even with demand. Is that where the solution is going to lie to really kickstart the long duration technology development? Yeah, what are your thoughts on co-location, whether it's with other storage technologies or with generation? Maybe I'll come to Priyanka first.
Well, we spoke about planning before, so well, if it's a congested part of the network and co-location really helps, then of course, but you have to think we are talking about longer duration storage here. So co-location becomes really important when over the day we're cycling up and down many times as we get the signal of what happens on the network. But long duration storage will probably play more of a role, and this is just me thinking, we have to do modeling and studies really to back it up. We'll probably be on a day when the network is free, there's not much congestion, but there is not enough generation either. And we just need to then fill in that missing energy supply from somewhere. So yes, if colocation helps with planning in terms of reducing the investment overall in getting the power to the storage and getting it charged up, of course, it's desirable in some way, but it could be equally located some other part of the network and get charged, because the cycles, as we spoke, is not that many times per day. It's probably multi-day, multi-week. It could be easily located in other parts of the network as well.
Okay, thanks, Priyanka. Gary, co-locating or hybrid storage systems, do you foresee one of your large systems, duration systems, with a ultra capacitor in the future, so you could got the full spectrum, or does your technology look to deliver every service that's under the sun? What about co-location? What are your thoughts?
Yeah, it's big on our list. We look for areas that we can have the biggest impact, and that is supporting, for instance, HVDC interconnector of the old style, where they have a requirement for stability. But then we would look at being there as well. It's a natural entry point to the system. Our first plant is more than likely going to be co-located with a large lithium ion. We see no competition there, but more complementary services, one being the longer duration, one being more rapid, in dynamic containment and some frequency response that we can't do because we're big metal pieces. Wind is definitely at the forefront of our thinking, because that's another grid entry point that requires support. The wind farm, when it's out of its subsidy, may be looking for a hedge for its power when the power prices aren't there. So yeah, and we're thinking about that now, and that, of course, that is 10-15 years in the future. Hydrogen electrolyzers require support as well. They're a big load, and and if you can't really just put that in a weak area, and our technology is very good at supporting weaker areas of the grid. So yeah, top of our location is top of our list, and that includes co-location.
Thanks, Gary. Shona, would you see a hybrid site or a site that could offer all of these services from one connection point as a more lucrative asset for you and your services that you require, or would you definitely like to distinguish between short duration services and long and generation services as separate parties?
Yeah, I think the important thing here is that there shouldn't be any distortions in the market design that give unintended consequences in terms of the business case for different configurations that don't reflect differences in the true value to the system overall. And this is something which often features in the distinguishing between assets at distribution voltage, distribution connections, and transmission level connections. Common problems in the market design is that different rules in those two connection options do introduce unintended consequences that aren't in the best interests of the minimizing system costs overall. So that would, from our perspective, that would be the main consideration. Yeah, obviously not having experience of projects ourselves for which we had to take that into account. Okay,
thanks very much. There are lots of questions today in the Q&A. Everyone's really diving in on this. Mindful, we've only got a minute or so to go, so I'd like to try and sort of capture a few of the themes that are in the leftover questions. So thinking big enough about the role of interconnectors as actually long duration storage, bundling assets, whether it's a societal issue rather than a system issue. Have we proved the case from these discussions? Have we advanced it along? Or if not, where do we need to put our effort? A question to all three of you. Is it something as simple as a long duration storage target, or do we need to dig into some of the things that we've touched on today? Where should we put our effort to prove the case? Maybe I'll come to Gary first.
Well, I've been working with the ESO on this for about 12 to 18 months now, where we both actively looked at deployment of long duration energy storage in certain boundaries to see if it made sense. So I think a bit more of the same, working together, understanding what the technology can provide. That's across the board, feeding that into the ESO, making the ESO know understand what your plans are, etc. Just good communication. And I think then that will help a lot.
Okay, thanks, Gary. Priyanka, what do we need to do?
First of all, really perform clear studies to prove that it will really drive down costs for the consumer, so the business case is clear. Probably provide stronger market signals in terms of how is this going to get incentivized, what markets will long duration storage feature in, how they will get remunerated, because that will drive a lot of developers and investors to look at it and actually bring it to fruition, so we can have that on the network. But most importantly, I think here is to finding the right balance. So we have a tendency in the industry, this is now the most important thing, let's do everything there and solve it, but then not looking at other aspects of it. So we have been talking about whole system for a long time, and a lot of questions were around that. How does it play into the whole system? I think that will be the most important question to be answered. How will long duration storage fill into the whole system, not just from electricity sector, but other sectors as well, and demand, including demand there in the mix as well.
Okay, thanks, Priyanka. And Shona, final words. What do we need to do to prove to you in terms of helping balancing the system? What do we need to prove the sector?
Yeah, so I think Priyanka made some really good points there. There's clearly various parties have conducted modelling exercises to inform this debate. So I think the really important thing is to ensure that those modelling exercises are as robust as possible and in different dimensions. So firstly, would you get the same answer if, for example, there were changes to the wholesale market that did more accurately reflect both temporally and locationally the value of power? And secondly, would you get the same answer once you factored in alternative outcomes in some of those whole system respects? So yeah, which take into account the alternatives to long duration storage across different vectors. So yeah, robustness of evidence to prove the case is critical for us.
Robust evidence, here we come. In that case, I think it's time to draw it to a close. I want to say thank you very much to my fantastic panel. I've had a great time personally. I hope everyone else has. It's been an interesting topic to dig into for an hour. So thank you to you all for your questions. Sorry we didn't get to all of them. And thanks to everyone who has participated in day 1 of 2 of the ESN Marketplace this year. We've obviously got more content coming up tomorrow. We're going to be talking about investment. We're going to be talking about dispatch data in the balancing mechanism for storage. And we've got a session on fire safety. So a real breadth of topics still left to come. And there's going to be some really interesting downloadable content on the Hoover platform for you to get your teeth into tomorrow as well. So day 2, not to be missed. But until tomorrow, thanks for joining us. Thanks for being part of the event this year. Please do talk to us about membership if you want to work with ESN beyond today and more. And keep networking. And thanks very much for your time. I wish you all a good evening.